Now, from the last few examples we have used using back substitution to solve the system of equations, you might be wondering, how do I get my matrix into row echelon form or reduced row echelon form? Well, it's very similar to solving the matrices or the system of equations analytically. But one thing is we only have like a few allowed row operations as we've gone over in the previous notes. And I'd like to kind of show you how this works by hand. And then we'll talk about other ways after we go through this. So a lot of times, once we get to this stage, maybe in maybe a linear algebra class or maybe finite math, what happens is we end up being able to perform the row operations in our heads. So pretty much we just do matrices where all of a sudden they magically change into either row echelon form or reduced row echelon form, and we get our solutions to X, Y, and Z. Well, I kind of found going through this is sometimes I just need a little bit more help when I start, so I will kind of write this out by hand, showing you exactly what I did. Eventually, if you have more practice, you take a later math class, you may see that, oh, you can do this with your mind, and eventually you can end up going through this process a lot more quickly. But we'll go step by step to start off with. So remember with the notation that they're telling us to do in this case, we're looking at part A, and it's telling us to take 2 times row 1. We're going to add that to row 2, and then we're going to replace row 2 with that result. We'll see if I can color code that with you so you can see what I'm doing. So that's going to be our new row 2 once we go through this. And you can do this mentally if you'd like, but I prefer to avoid a lot of minor errors. So if you don't mind, I will show you kind of my idea. I just take the -2 and I take the top row of my matrix. So 1, 3, -3, and 4. And what I'm trying to do is I'm going to multiply the -2 by all of the numbers in that row. So it's kind of like distribution. So this will leave me with a new row, -2. So -2 times 1. -2 times +3 is -6. -2 times -3 is +6. And then we have the equal sign. And then -2 times +4 is -8. So that's our temporary row 1. And what we're going to do is we're going to add this to our row 2 that we already see. So that is going to be 2, 5, 9, equal sign with 0. So what I end up looking for is I add. And then notice what happens if you add vertically. The 2's cancel out and we get a 0. The -6 plus 5 ends up being a -1. 6 plus 9 gives us a 15. And -8 plus 0 gives us a -8. So we end up having our new row 2. Let's write that a little nicer for ourselves. New row 2. So what they're asking us to do is pretty much ignore everything else and just replace the row 2 with our new result and rewrite the matrix as is. So what happens? My actual answer to part A, I would have to write the top row is going to remain the same, 1, 3, -3, 4. The second row will be 0, -1, 15, -8. And then the third row is still the same as our original, 4, 1, -8, and -6. And so notice with this particular sequence of row operations, we are starting to build the lower left triangle of zeros, or we're trying to. So I do see that 0 below that that below that first leading one. So part B, what we're going to do is take our matrix answer from part A, and we're going to do the same process, only we'll be using the answer from part A from part B. So you're just adding on or attaching on to your matrix. So let's go through this. I'm going to look at -4 times row 1. So if we could kind of look at that together. My row 1 of this previous matrix, and it's actually still the same as the original matrix. We are going to add this to row 3. That's over here. And then what happens is we're going to have to replace the row 3. That's what they're trying to say with capital R. So if we do this, you kind of see my mental math out on paper. If I say -4 times row 1, remember row 1 in this previous answer is 1, 3, -3, and 4. So let's do the math on that. -4 times 1 is -4. -4 times 3 is -12. -4 times -3 is +12. And -4 times +4 is -16. So we will take this and add it to the row 3. So that was in our previous matrix, 4, 1, -8, equal sign -6. And notice if you add, I think I'll do that in red, add vertically, the 4's cancel out, so we write a 0 in this place. -12 plus 1 is going to give us -11. 12 plus -8 is going to give us +4. And -16 plus -6, we should get I believe it's -22. Yes. Okay. So if we have this, what this is our new row 3. Let me make sure before I say anything, we're in good shape. Okay. And let's write our answer. I always have to double check. Always make sure I have this down. Now, normally you're not scrolling back and forth between screens on your paper, so it's a little nicer for you. So what we're going to do is take our previous matrix. The only thing we are replacing is row 3. So that's kind of where our replacement is. So that's going to be 0, -11, 4, and then -22. And then everything else from our previous answer is rewritten. So 1, 3, -3, +4. 0, -1, 15, -8. And now we have our new matrix. And notice when we're going through this process, we do see that lower left triangle of zeros forming. Now the third row has a leading 0. So this is good. So you're probably guessing if we're looking for a lower left triangle of zeros, we're trying to figure out how we can get this -11. See if I can highlight that. We're trying to see if we can make that a 0. Now, other classes will tell you that you're in charge of figuring out how that could happen. Well, let's say you take a class beyond college algebra, feel free. But right now, part C is just getting you into the swing of things and trying to let you know this is how we would do that. So let's go and talk about this notation. What we're looking at is, let me see if I can talk about -11 times row 2. So I will use, I think I'm going to use teal this time. And what I'm taking is the row 2 from my previous answer, multiplying that by -11. I'm going to add that to the row 3 of my previous answer. And again, I'll be replacing that previous row 3 one more time. So we're going to replace that row 3 again. So let's take those steps. Let's go with negative 11. If we're multiplying that by the row 2 was originally 0, negative 1, 15, and negative 8. I need a calculator here because I've seen that 15 there. So let's distribute that negative 11. So negative 11 times 0, that one's nice, 0. Negative 11 times negative 1, that's going to be positive 11. Now negative 11 times positive 15 gives us negative 165. Negative 11 times negative 8 is going to give us positive 88. So we're going to add that to our row 3. So our current row 3 is now at 0, negative 11, positive 4, and negative 22. So let's do that together. Add vertically. We have zeros, still 0. Negative 11 plus positive 11, we have another 0. And negative 165 plus 4. What do we have? Negative 161, I believe. And then we do get 88 plus negative 22, 66. So let's finally write our final matrix. Now remember what row was supposed to get replaced? We're going to have a new row 3 once again. So my row 3, I'll start off 0, 0, negative 161, and a 66 as the constant. And then we'll repeat all of the other entries from our previous matrix answer. So 1, 3, oops, let me line up the numbers, that would be nice. 1, 3, negative 3, and positive 4. 0, negative 1, 15, and negative 8. And then you notice with our answer, you do see that we are going towards getting the diagonal ones, but what's really more important is looking at our lower left triangle of zeros. So hopefully this helps give you a little bit experience in how we would go about turning an augmented matrix into row echelon form. And eventually the goal would be reduced row echelon form if we're really trying to solve the system just purely by using matrix math. But just want to get you a little taste of it, and then maybe we'll have another trick for you to use instead of doing this by hand. You'll just have to stay tuned and see. We'll see you in the next example.